So this lesson in which we continue to work with probability, one of the main parts of it is understanding some of the notation. Notations such as this, which are called intersections, and this, which are called unions. And quite often they're great to visualize with a Venn diagram, which I'm sure you've seen before. So let's get to an example which has a tree diagram. And then I'll get to an example with a Venn diagram. So I have here a tree diagram showing you the possible outcomes if you flip a $1 coin and then a 5-cent coin. And again, when you have a tree diagram, each pathway shows you a particular possibility. And so in the end, we can see there are 4 different possibilities when you flip 2 coins, which is the number of elements in the universal set, which is what the first question is asking. So NU means the number of elements in the universal set being the sample space, all the possibilities. And that's what a tree diagram shows you. It shows you the ends of the branches, show you all the different possibilities. There's only 4 possible outcomes here, so this equals 4. Now with the probability of there being, when you flip these 2 coins, of no heads at all. In this case, for a simple scenario like this, I can just see that this is the only example right there. So having no heads means having 2 tails, which is just a 1 in 4 probability. The next part we call the complement. The probability of at least 1 head means everything else. It's having at least 1 head means not having no heads. And so in this case, I can see the answer by looking at it. There's 3 possible outcomes that have at least 1 head, and including one that has 2. So I can just see the probability is 3/4. But as we get more complex scenarios with many more elements in the universal set, we quite often can't just count them, and quite often it's more helpful to realize this must be the same as 1 minus the probability of no heads. We saw something similar yesterday with these at least questions. And so having at least one of these heads is the same as everything else, 1 minus everything else, which in this case is 1 minus the probability of no heads, which we saw from the last example was 1/4. And notice 1 minus 1/4 is 3/4. Now in this case, like I said, it's probably easier just to do what I did at first. But this is too easy of an example. It's a good start, just don't expect to see things quite this simple. And this idea of at least and finding what we call the complement, which is instead of directly finding the answer, going 1 minus everything else comes up a lot, especially for these questions. So now going to Venn diagram. So what we have here is a Venn diagram showing you the number of students, the diploma candidates in IB Art and IB Music. And so first, if we look at what this means, keep in mind this 24 down here means there's 24 students, 24 candidates who are not taking art or music. There's 3 students who are taking both art and music. There's 15 taking just art, 18 taking just music. Very common way of showing how data that overlaps can be, broken down. And so for this, I want this here is the number of A, and we call this the intersection of A and M. But what does that mean, the intersection of A and M? This means the number of students who are taking art and music both. That's what this means. Who take art and music. And in this case, quite often we can imagine this symbol here kind of representing the word and that I'm saying both. So how many students take art and music? Just those 3. And so this equals 3. This here is the union. This means art or music, or both art and music together, all of them together. And so let me just write that down. Take art, and I'll say or take music. Which means everything inside here, all these students here are taking art or music. That includes this group of 3 that are taking both. That's okay. This union just means all of that together. So you don't exclude these because they're taking both. We also don't count them twice. So in the end, how many students take art and music, or art or music, I should say? We have the 15 who just take art, the 18 who just take music, as well as the 3 who are taking both. Add those all up, and we got 18. How on earth did I get 18 there? That does not make any sense. Oh yeah, because it doesn't get 18, it gets 36. If I was a little less lazy, I would edit the video right there. Nah, not gonna do it. All right, so again, this is called, the one I've highlighted in yellow is the intersection. The one that looks like a U is the union. And union means combining. Intersection is where they overlap. All right, when we see a little apostrophe right here, that means the complement or like not. And so one way of looking at what this means, it is an intersection, but this is how many people don't take art, but also take music. Because this is an intersection, so we have to think where they overlap. So how many students don't take art, but do take music? All right, so if we look over here, all of these students here that I'm highlighting, or maybe I'll just highlight the numbers, all of these students here, here, and here are not taking art. But we want to find the intersection of that with how many students take music. So that intersection is just right here. That 18 are the students who are not taking art, but are taking music. And that's what this notation means here. We're the complement of A, so not taking art, but are taking music, where they overlap. And so this is the 18 I was looking at before. Silly me. Right, so the last three now are probability questions, but the same, very similar to before. And so the idea being, okay, what if we selected a student at random from these 60? What's the probability of this? Which means what's the probability that the student, goes back to this, takes art and music? That's what this is really asking. Select one of these 60 students at random. What's the probability that they will be enrolled in both art and music? So it's just this 3 out of the total, the universal set, which is 60. And so the probability of this is just 3 out of 60, which reduces to 1/20th, which I might as well reduce it. And similar idea for the rest of these. This one here goes back to this here. The number of students who take art or music was 36. So the probability of selecting a student at random who takes art or music is 36 out of 60, which reduces to 3/5 in this case. And the last one, the probability of not taking art and taking music. Well, let's find how many students don't take art and take music. That was 18. 18 out of 60. I just realized my last question. I'm on a roll today. That should be 36 out of 60. I wrote 36 over 30 because there's always 60 students in total here. So we have 18 out of 60, which reduces to 3 out of 10. All right, so keep in mind if I just get rid of all my writing here, the actual calculations are extremely simple. The hardest part right now at the beginning is understanding what this represents. And again, every time you see that apostrophe, we call it the complement. You can think not, whatever it is. And so lastly, I have a Venn diagram that needs to be completed. So I have a survey was conducted on 30 students in which they were asked if they enjoyed attending math and if they enjoyed attending English class. And I'm giving you some of the results below. And so this here, P equals a half, that means the probability of a student enjoying English class is 1/2. Or you can say that means half the students enjoyed English. This here, PM equals 8/15. That means the probability of a student enjoying math was 8/15, or 8 out of 15 students enjoyed math. This is the trickiest one. This means the number of students who enjoyed math and enjoy English, that's what this represents, but not that, so the complement of that. So put that all together, this means the number of students who don't enjoy both math and English is 5. So we know there's 5 students who enjoy neither math and English, and that's what all this represents. The union of math and English is how many enjoy both, but it's not those. So that's the first part I can actually show here. I know I can put a 5 somewhere outside here. I'll put it down there. So there's 5 students outside of this. I also know that there's 30 students in total, which means all of this here must have a total of 30 students. Okay, so I know that. What else do I know? Well, if I look at English, this is half the students enjoy English, half of 30. So I know this leads to half of 30 being 15, 15 students. I have 8/15. Not quite as nice of a fraction, but a little bit more than half, because of course, slightly more students enjoy math and English. And so 8/15 of 30 is exactly 16 students. Now here's where we got to be careful. That means there's 16 students in total in this circle, and there's 15 students in total in this circle, but some of them are in both. And so we want to be wary of doing something like this, of saying, okay, there must be 16 here and 15 here. Well, first of all, notice this adds up to too much. 15 plus 16 plus 5 is more than 30. I only have 30 students in total. So those numbers aren't meaningless, but 16 again is all of this. So how do I know what do I have here? Well, keep in mind, I know that these two together must add up to 25 because there's only 30 students in this group. And yet these two add up to 31. Which means there must be 6 people that I've counted twice. This 31 must involve 6 students that I've counted twice, because again, I know there must be only 25 students in both these circles together, which means those 6 students I've counted twice must be the ones who are in both. Which means now I got some simple arithmetic. I know there's a total of 16 students who enjoy math, 6 enjoy both, which means there must be 10 who only enjoy math and don't enjoy English. And likewise for English, there's 15 students in total who enjoy English. There's 6 we've already counted, which means there must be 9 others who only enjoy English and not enjoy math. And just to double check, just keep in mind, if I add all these together, I should get 30, and I do. If I add these together, I should get 16, and I do. Add these together, I should get 15, and I do. And if we make common mistakes, if we just check, you can figure them out quite quickly. And usually our mistakes are when we double count things. Like I said, those 6 students who enjoyed both.